Today I'm going to discuss the tasks given in assignment 2. So the first task was to identify the point group of crystals. And by glancing at the crystal that was given to us and getting a feel of its morphology, we could say that there are three two-fold axes present here. So which is a feature of orthorhombic crystal system. And so we can say, based on that, we can say that the point group would be 2, 2, 2, 2. This 2 stands for the two-fold axis present. Now, these are the two-fold axes, 1, 2, and 3. These are the three two-fold axes. Now, the second task was to solve and refine the crystal structures of three datasets in OLX2. We usually begin with loading our .ins file into the OLX2 software, and after that, we perform a preliminary step of solving that crystal structure using shell access module. After that, we get a electron density map, and based on that, we assign atoms which we feel are there, and then we perform the refinement operation using shell excel module, and further refinement of parameters is performed if the assigned atoms agree with the plausible atom position in the crystal structure. However, if they do not, we go back to the previous step and we assign the atoms again, and then we perform the refinement again. But if they do agree, then we move on to further refinement steps, and after we have achieved a minimum value of residual factor, we generate the crystal structure data files, which can be used for further analysis. Now, here the most important thing is the shell access module and shell excel module. They should be present in the OLX2 software directory to work. Otherwise, they won't work. Now, this is a visual of how the OLX2 software looks. So firstly, we load the .ins file into this OLX2 software, and from there we move on to this work tab. It opens up these subsidiary tabs. Here we use this solve tab. So firstly, we can see that we are using shell access module, and to begin with we are using direct methods. However, if you see that your compound or your crystal has heavy metals, then you can go with the Patterson method as well. Now, one thing is, if you see a space group given, and you can also say ask them to suggest another space group, and if they do, you can use that too. However, we run this by clicking on this solve button, and after that we get this electron density map. Here we can make sense of it that these look like a six-membered carbon ring. So we'll assign them as carbon to begin with, and then usually people assign a few atoms at a time, and then they run a refinement, then they go back and then they assign some more. So it's a cycle, that's how it goes. However, I've assigned all of these atoms all at once because I've already performed this step several times, so I know where each atom is supposed to be. And after this, we run a preliminary refinement which gave us some value which was not minimum, so that means that we need more refinement. So we added the anisotropic refinement, and then we added hydrogen and used several other factors to achieve this minimum value of 3.18 residual factor. And once this is reached, then we move on to generate the data files for further analysis. Now, these are the solved structures of all the three data sets that were given. This first one is the for the data set 1, and here we achieved a residual factor of 3.64. Second one was data set 2, and here we have achieved 3.63. In third, this is the data set 3, and for this the residual factor achieved was 3.18. Now, third and fourth tasks were to visualize a crystal packing diagram in Vesta software, and then simulate a PXRD pattern using Vesta software. So this is just a sample. Here I've used the dataset 3, and this is how it looked, the crystal packing diagram of it, and this is its corresponding simulated pattern, PXRD pattern. So in Vest, these are the steps that we follow in Vesta software. So this is how Vesta looks when it starts. To start with the analysis, we go to this file menu and we load a crystal.cif file from there. And once we load that .cif file, it gives us a crystal packing diagram which look somewhat like this. So now we can perform many operations here, but since the task at hand is to generate to simulate a PXRD pattern, we go to this taskbar and we see this utilities tab. When we click on it, it it gives a list of tasks that you can do. So from that we selected uh, PXRD pattern simulation, and by selecting that it opened a dialog box like this. Now when it opens, it's an empty dialog box, so we press on this calculate button and it generates this PXRD pattern, and then we can export this data for further analysis and whatever we our purpose of doing it. And this is how we completed the task.